Hello everyone, I am Praveen and this video is about the Task-2 for Data Science Intern of the Sparks Foundation Group program. So the task is to perform prediction using unsupervised machine learning, and we are given with the dataset, that is RDS dataset, and we can use either Python or R, and I am going to be using Python, that is Jupyter Notebook. So let's proceed. So the first thing I did is importing the libraries, pandas for data manipulation, numpy for numerical functions, and matplot and cbond for the data visualization. So here I imported the dataset, and then I just used the variable to get a brief look at how the dataset looks. And then I went and did some analysis, the exploratory data analysis, by using data.shape and data.info. From this, we learned that there are 150 rows and 6 columns, including the ID, which we don't need. We are already getting a default ID column, so I have removed that later on. And we also got to know the data types of each of these features, each of these columns, and that there are no null values. After that, as I said earlier, I have dropped the ID column, and then I went and checked if there are any duplicate rows in the entire dataset, and we got to know that there are 3. So here I dropped them, so we have 147 rows currently. And then I went ahead and plotted box plots for each of the features other than, of course, the target variable. Those are sepal length, sepal width, petal length, and petal width. So among them, the only problem is with sepal width, which has few outliers. So I've used the lambda function here to remove those outliers, and as you can see now, it is fine. The next thing I did is I just plotted a count plot, and as I've already mentioned earlier, 3 of the rows were removed because they were duplicates, and as we can see here, 2 of them were removed from iris setosa and 1 from iris virginita. And finally, I've used data.describe function to just data count of all the rows from each features, mean of each column, standard deviation, minimum, maximum, and each quadrant. Once it is done, I went and did some data visualization. As you can see, it is a density graph for each of these features. And after that, I have visualized the correlation matrix as a heat map. So from this, we can infer that petal length and petal width has the maximum positive correlation, that is 0.96, and sepal width and petal length has the least correlation, that is 0.42. The one shouldn't be considered because they are being mapped over to themselves. Then I went ahead and divided the dataset for the training. As you can see, all the features other than the target variable are being put into X. Then I went ahead and used the elbow method to find the most optimal number of clusters. We know that it has to be 3 because there are 3 different values, unique values in the target variable, iris setosa, versicolor, and virginita, and it is just proved from this elbow method, which is 3. And then I used the k-means inbuilt k-means function to perform this model, and as you can see, we even got the cluster centers. And then I have plotted this in different colors. So iris setosa are plotted in red, versicolor are plotted in blue, and virginita are plotted in green. And the yellow dots are the cluster centers that we have found using this function. So that's it. Thank you very much.